Why we need assemblers? Oh, then some hex coding for start would be needed to show how tedious it is and what assemblers offer compared to hex coding. Let's try with those then. This is my DOSBox machine. Yeah, the information about disk space doesn't matter here. This is DOSBox that has emulated disk just as a directory on my main machine. I think the only hex editor I have here is the one built in DOS Navigator. This one. The problem with it is that I'm not able to insert values. I can only replace. Yeah, we can fill the area with knobs or something for start and then replace. Let me try one more thing. This way I can write some additional notes. So let's create our first program. Find 90. This is now pre-filled with knobs. We need some basic codes, and some of them we did not talk about last time. A simple file that does nothing. Well, it would have to at least be able to exit to DOS. So either this one. This is code of instruction interrupt, and this is interrupt 20, the one that ends COM program. Yeah, it works, okay. Alternatively, you can use stack, because COM program has a specific layout that allows it to exit just with read instruction. So just a single byte is enough then. C3 is read. The layout of COM file in memory is such that first 256 bytes are so-called program segment prefix, PSP, and the program is loaded after that area. Also, the very beginning of segment, offset 0, it is the beginning of program segment prefix, and it starts with with these 2 bytes. So if you jump to 0, you're going to jump to instruction interrupt to O and exit program. Another interesting fact is that the value on the stack initially is 0. So if you pop a value from the stack, you pop 0. If you return, you jump to 0. Oh, I have an idea. I could show that in debugger. Oh, DOSBox does not like this debugger. It seems to hang. But you can see at DS000 there are CD and then 2O bytes. So we can see that program segment prefix starts with this instruction interrupt to O. Unfortunately, I have to restart DOSBox. So let's just code in hex for now. I'm going to write a little reminder of the register order in encoding. So this is digit 0, digit 1, digit 2. Octal digits. I need more space. If we converted the hex B0 and B8 numbers to octal, this would be 26 and then code of register, or 27 and then code of register. Again, another case when octal system would be more handy, but we are writing in hex, so we need to convert it to hex anyway. Well, I have a nice handy calculator here too. It is in fact the calculator that inspired the one that is in FASM. Oh no, I never coded in exponential. Now, this should be enough to write a simple hello world program. So let's go for it. We are going to call function 9 of interrupt to 1. Number of function is given in AH register. And the X should point to text. First, let's put 9 into AH register. This should be B4 to move into AH. Then 09, the value to move there. Text should be terminated with $sign, 2 for hex. Next, we need a pointer to text in the X register. This should be B89A to move into the X register. And then 16-bit value, word. We don't know the address yet, so let's just leave it as 0 for now. Then we call those interrupt to 1, and then exit program interrupt to 0. And here we can start our data. Hello and $sign. This is at offset 9. But, as I said earlier, data segments start with program segment prefix, and this code ends up loaded at address 100 hex. So this is in fact address 109 hex. little endian, so first 9 and then 1 all. And let's see if it works. Yes. Now we can add something here. We can add wait for key function, so that it does not instantly terminate but waits till we press something. This hex editor does not have insert function, so I need to overwrite the bytes. This is the function that should wait for key press. Zero to AH. This and terminate the program. We have scrambled our text. It works, but it is scrambled. So we need to move our data up. Now the address is OD, so we need to fix code here to point to a new address. Great, it works now. And here we come to the question what the assemblers are for. Because you see, you often hear that assembler just provide mnemonics for instructions. But when you are accustomed to these instruction codes, you could write them from memory just as well as writing mnemonics. Well, depending on people. Some people better remember text, perhaps. Most people probably better remember short words like moth. But this is not so much difference. The actual difference that assembler gives is that you do not have to modify addresses in every instruction every time something moves in code, because you had to insert instruction there. In fact, we can rewrite the same hex code in assembler like this. And now what we can do with assembler is make a label and use it here. Oh, in this case modified to take PSP into account, or we could just write org. And this is something that we could assemble with FASMG, raw FASMG without any macros. And this is, I would argue, core of what assembler provides. It's not important to have mnemonics that replace these codes. You can just write macros that do the same, that do provide mnemonics. But this is something that assembler needs to be able to do. To put right values into places, right addresses. Now I have the source here. If you ever need to run a Windows console application in DOS, this is the way to do this. So this is what raw FASMG can do for us. And this is in fact, like I argued earlier, the core of what assembler needs to do. We can now insert more instructions here than earlier. Function 2 is to write a single character in DL register. we have added the $sign that could not be written out by the first function. So you can then insert code just like we did here and not worry about this instruction needing an update. The right address is there because assembler does it for us. Yes, G is just after F. The original thought was to just increase the letter, and next generation was a later explanation for that. Well, gas was not only not just taken, but also sounded a bit like something not assembly related. Yes, orc is also important here. Yes, default is orc 0. Alright, what next? Do we stay at DOS? Well, exe, there are many fields in headers to fill. Not hard, but tedious. Well, okay, we can write down the instructions. We can take a look at the example. These are all the fields we would need to fill, calculate and fill. As you can see, quite a bit of macros here for various settings. Oh, MZ does not have PDP instructions, it is portable executable PE. Yeah, so we can just take the macros and use them. We also need some instruction set. Set up entry point. Set up data segment. Oh yes, I could encode it this way, but I prefer to separate this ending character so that it is clear that it is not displayed. And now we cannot use this function to exit program, because this function requires CS register to point to program segment prefix, PSP. And here CS register is this segment code, because this is how we set up entry points to our program. So this would not work, we need to use another function. This is a function that allows exit code to be provided. and it is often compressed into this form. Alright, this works. Well, we could set up it such that this function would work. Instead of code, we would have to use segment that has program segment prefix in it. Segments are numbered every 16 bytes, so-called paragraph of memory. So a difference of 100 bytes is a difference on 10 of segments. And now we have to adjust addresses within our segments too. Let's try it. Yeah, it works. And perhaps for comparison we could go back to try using this function when the segment is not PSP. I'm prepared to restart DOSBox soon. Oh well. It did still exit. Somehow. So now, it works. It should not work. Don't do this. And yes, if you would be doing this all by hand, all the values here would need adjusting every time some sizes would change, some offset segments. You provide the size of the code as a number of 512 byte pages, and then if the last page is smaller than that, then you have additional field that gives the size of code in the last page. This is so tedious that I did not even try. Oh, and relocations too. We have a relocation here. This instruction needs relocation because we don't know where the program ends up in memory when DOS starts it, so we don't know what is the actual value of data. So executable just contains a relative value of this segment, and this instruction is corrected by relocation when DOS loads it. If you read my PE tutorial, the relocations are nicely summarized there. How to implement them with macros in FastG. The same could be applied here to MZ. Let's go for something fun now. Mode 1.3, anyone? Oh, I forgot about the I. Something's wrong. Oh. Horizontal, not vertical resolution. All right. And now we can make some image in a loop, perhaps. This should not be here. Yeah, every pixel was just the color was a XOR of its coordinates. For me, that's one of the simplest things I can do in graphic mode. Oh yeah, demo scene was things like that, but much better. This is a very simple basic code. Oh, for me, DOS music was much more complex to code than DOS graphics. There were no BIOS functions for music or sound effects. You had to do it all manually, depending on sound card model. Different ports could be used for different model, or even different settings on the same model could use different ranges of ports. Setting up DMA was also not so simple thing. And you needed DMA for sound effects in order to free up CPU to do whatever else you needed to do, and not just sound effects. Yeah, Fast Tracker was a very impressive piece of software. One of the best of its day. Let's go back to larger screen there. Oh, here it is. This is Bootable, not a DOS program. You boot into it directly. Oh wait, I think I can just boot it from DOSBox here. Yeah. How many hours did it take? I think it was perhaps a single day, not much more than that. One of the tricks for size I used was to use interrupt-free instruction. This is a single byte instruction, as opposed to 2-byte regular interrupt. And this is just a function call. I just had a function that was hooked into interrupt-free, and I could call this function this way with a single byte. In addition to that, this function, as an argument, takes an address into another function. So this is a bit like a, I don't know, lambda function or something like that. Yes, this was a long time ago. We were living together with Ender at that time. Well, this Tetris was, in fact, considered a bit non-standard, but I mimicked the Tetris that comes with DOS Navigator. This one. It plays very similar. And the size of well is the same. And the way pieces rotate is the same. Well, original Tetris had a different size of well. I do not remember exactly, but I think it was not as wide as this one. Is there anything else you would like me to do? In those, perhaps? Otherwise, I think we are going to wrap it up. That's all for today then. Thank you and see you next time.